All right, so chapter 12 is all about secure communication and network attacks. All right, so in this chapter, some of the things we'll be covering include voice communication, going over that just a little bit, talk about remote access, load balancing, go over some different types of that, email security, as well as network security. All right, so right off the bat, we know there are two primary types of voice communication. Okay, what are they? Okay, so we have analog. What else do we have? Digital. Okay, so private branch exchange. All right, what's going on there? Okay, we have an internal phone network, and it's analog. All right, so if something's analog, what does that mean about encryption? Okay, in this context, it means it doesn't exist, right? So, with PBX, is it possible to eavesdrop on calls? Okay, you guys have heard about the what are those devices that you can listen in on phone calls? Not a bug. What's the technical term for it? It'll come to me eventually. Wiretap. Thank you. Okay. So wiretap. It's a concern for a PBX system, is it not? Okay. So, having said that, same thing with public switch telephone network. All right. The name public implies that it's not just yours. All right, and that could be a very big problem. All right, imagine you were going through and you were discussing plans for some new intellectual property you're trying to secure. So let's say you've already done the R&D efforts to obtain it. Okay, so you spent millions, possibly billions of dollars. Okay, and you use an unsecured medium like a PBX or PSTN system to discuss it. Could that be bad? Be very bad. All right, so you also got VoIP. Okay, so voice over internet protocol. If it's over internet protocol, what does that mean the signal is? Analog or digital? Okay, so once it becomes transmitted, it's digital. So that's certainly something to keep in mind. Some different ways to protect it. Obviously, you want to use strong passwords. All right. So you might be saying, well, passwords to what? And that's a very good question. Okay, anything associated with the VoIP system. So for instance, say you had a VoIP server. You'd have strong passwords, multi-factor authentication, but that's not how you would end, okay? You would also want to have very strong access controls for that server. And it probably makes sense to only allow access from certain IP addresses. Now, none of those things by themselves will protect it, but the combination of those certainly should, right? All right. Want to consider recording of calls. All right, why would you want to consider this when you're building out a VoIP system? Why does recording of calls matter? First of all, are there regulations in place regarding recordings of calls? Laws and regulations. Okay, think about one-party versus two-party consent. All right? You guys know what that's referring to, right? So Colorado is one-party or two-party consent? It's one-party, is it not? Okay, so Virginia is a two-party consent state. That means that both parties must consent to an audio recording. All right. Colorado, I'm pretty sure, someone look me up and double check this, but I'm pretty sure they're a one-party consent state. So as long as one party's aware that the recording is taking place, it's okay. Yeah, I think that Virginia's the famous two-party consent. There's a few others as well, but Virginia's the one that everyone always thinks of. All right. So you'd have to consider that. Now, okay, one thing you could do to inform people that the call is being recorded, play a tone every 15 seconds. All right, you guys have been on phone calls like that before, I'm sure. Is that kind of frustrating? You're talking and then you hear a beep a little bit. Okay, another thing is to simply announce it at the beginning of the call. All right. You can also, of course, employ block lists for VoIP systems quite easily. Okay, you can do it with PBX as well. Okay, it's certainly not an impossibility. However, with a PBX, okay, it's purely analog, so that means there's no verification on caller ID. Okay, whereas with VoIP, you can verify caller ID information. All right. This is going to be pretty beneficial in a lot of cases. You guys probably get robocalls, right? Okay, people calling you about your extended car warranty. You guys know what I'm talking about. All right, have you guys seen the memes about that, where they start like going underneath people's porches and talking about it? You guys know what I'm talking about? Okay, you can block that with VoIP pretty simply. All right. There's tons of different ways to go about a block list. You could, of course, similar to a malware list, you could, of course, subscribe to someone else's. You can make your own. Just a lot of different ways. Okay. Probably the most important benefit of VoIP over non-VoIP is that you have secure real-time transfer protocol you can use. Now, I'll go ahead and say the obvious downside with that is, does that work for outbound calls in most cases? Okay. It mostly only works for internal calls. Because how can you ensure that the person you're calling has access to SRTP as well? Okay. It's not really a great way to do that. So with any of these, it's probably not good to call outbound numbers and discuss stuff that is confidential. But for internal, VoIP has a clear advantage. Now, what's the other primary reason that in 2018 most businesses began transferring everything over to VoIP from PBX? What's the big reason? Exactly right. Okay, there's a regulation. Okay, I don't remember the name of it, but what happened is there's a motel or something, and some girl tried to call 911. Okay, and she dialed 911. Problem is that most systems, PBX in particular, the first 9 is just getting out. So she was dialing 11 instead of 911. So she should have dialed 9911. Okay, you guys understand that? All right. Now, again, I'm not here to state an opinion on regulations, but that's certainly pretty costly. Okay, transferring from PBX to VoIP, even if the operational costs are substantially lower on VoIP, that's a big upfront investment. All right. Having said that, the regulation says you have to do it. I'm not here to say you have to do it. I'm just here to say the regulation says you have to. Personally, I don't really care what you do. All right, let's talk about vishing and phreaking. All right. Now, I'm personally not a big fan of them putting the ishing on everything. You got phishing, you got spear phishing, you got smishing. So many ishings. It's like, goodness gracious. All right. So vishing, simply phone phishing. All right. So you're pretending to be someone you're not. That's all we need to say about that. Okay. Anyone like the 8-bit guy? Anyone? He's got a really interesting video if you want to watch a 30-minute, talk on phreaking. All right. It's pretty interesting. I'm not saying you have to watch it or anything, but I'll give you a good summary of what phreaking is. All right. So it has to do with using the same audio that a phone system would expect to hear. This is particularly true with analog phones on PSTN. So, think about the dial-up noises. Anyone old enough in here to have ever used dial-up? Okay. That's what you're trying to emulate, basically, those types of sounds. All right. And that's used to do things, like get free long-distance calling. Now, that's not really a concern for modern day, is it? Okay. Because what do we know about long-distance calling? It's free anyway. Okay, at least on the vast majority of phone plans. All right. You can also spoof caller ID with it. That's not a common use. Like I said, I mean, most of this is like the 70s and 80s, people trying to get free long distance. Could use it for stuff nefarious, like tying up phone lines if you wanted, getting free dial-up. But again, none of this really matters anymore, does it? Okay. So they say it's used in modern systems. I'm not sure I agree with that, but if it is used in modern systems, it's going to be used to basically access a VoIP server. All right, remote access. So a couple different ways we could go about this. They pretty much all revolve around using a virtual private network connection. Okay? So pretty self-explanatory. You have a company, and let's say Ron's working from home. So here's Ron. Okay, he has his little house or whatever. That's a house. That's not the best drawing of a house, but that's a house. All right, and Ron's trying to connect to the company. All right, so he may establish a VPN to establish a virtual private network tunnel. All right, that's certainly one way Ron could go about it. Okay, Ron may also use a virtual private cloud. Okay, as the name would imply, it's going to be something hosted outside the company, but you can connect to externally. Okay, so they may have virtual desktop interfaces that are not on premise, so not inside the company, but inside of a different company. And he'd choose to connect to those. And of course, a virtual desktop interface would be something like using a virtual lab. Does Fort Lewis have a virtual lab? Okay. So when you sign on to the virtual lab, I'm assuming that it's like using a standard desktop. It's just not your desktop. Okay. How do you access the virtual lab, by the way? Cool. Didn't know we had that. That's a good thing to have, though, because there's a lot of software that you can't get a license for. Well, you can. You just have to pay for it. All right. So virtual desktop connection is a little bit different than VDI. Okay. So the difference is you're literally connecting to a physical desktop, a virtual desktop connection. Okay. So VDP, of course, is a protocol for that. VNC is what we often refer to it as. Cloud-based, again. Cloud-based, the only difference is that instead of having it hosted on your company, it's hosted on a different company. There's a lot of big names in this, cloud-based. Of course, you have Azure. It's going to be a big one. A lot of AWS stuff is arguably related to this. But some best practices keep in mind. You have to be usable, number one. So, if Ron's sitting at home, he has to be able to do his work, right? Ron, you want to do your work? Okay, Ron wants to do his work. So, ensuring that stuff is usable. Okay, that means there's not too much burden to connect to a system. However, having said that, it's also important that this information is secure. Okay, Ron, you don't want to cause a big data breach, do you? Okay. So, each of these have the ability to use some sort of encryption, some better than others. Okay. But in general, if you're on a VPN, it's likely using either IPsec or AES. That's pretty secure, right? Okay, it's certainly possible to breach those, but is it feasible to breach those in real time? Likely not. Now, if you're a big enough target, okay, that could be a different story altogether. All right, let's say you have enemies with, I don't know, pick your favorite nation state. All right, you get an entire nation state against you, you think they can breach 128-bit encryption? Probably so, right? I don't think that's too impossible. Now, 256-bit, that's going to take more resources, substantially more. Okay? Remote meetings. So, always consider where the tool is coming from. That's probably the most important thing with remote meetings to keep in mind from a security perspective. So, let's say you're an American company. Should you use a tool with Chinese origins? Why or why not? Okay. Zoom. Should you use it? Why or why not? Have they been accused of having Chinese origins? Yeah, they have. They've been accused of sending data to China. Should you use it? Might make sense to not. I'm not here to tell you what tools to use. Think about something like Microsoft Teams. You know, you trust Microsoft. Well, regardless of whether or not you trust them, do they probably already have your information anyway? Yeah. Okay. So if they already have your information anyway, and they give you a tool that's built into 365, why would you not use it? All right. But I'm not saying you should. Feel free to disagree with anything as well. But always consider where the tool's coming from. You know? Let's face it, okay? If Pakistan made a remote meeting software, should you use it? Probably not. All right? Just being blunt, okay? Tool origin is extremely important. Now, let's say you're evaluating several remote meeting tools as a security professional. What should you look for? What should we look for? Someone name something we should look for. Something basic. Encryption. That's a good thing. Should we just straight up scan the tool for malware? Yeah. Okay, what else? A lot of them are up here. Okay, origin. This is real. That might not be politically correct to say, but, you know, if you have a nation that hates your nation, why would you use their stuff? What else? Same reason you can't use Kaspersky in the government, at least the United States government. All right, why not? Where is Kaspersky based? Moscow specifically. Okay, you know, can't use it on U.S. government computers. It's not my rules. Okay. What else? How about where it sends traffic? All right. So you would consider where the traffic is going. All right. And that's both inbound and outbound. All right. Imagine you have a piece of software that's receiving a lot of packets from Chinese IPs. Is that going to raise some eyebrows, maybe? Should. Anything else we want to consider? These are some good start. How about authentication? Okay. So specifically, what are we looking for here? A couple different things. First, we're looking for integration. Does it integrate with, say, Active Directory? Does it integrate with LDAP? Okay, those are important. What else are we looking for? We're looking for multi-factor authentication. Does it support the use of maybe external authenticator? Okay, Duo is an example. Maybe Google Authenticator is another example. Maybe even stuff like a YubiKey. All right, those are going to be important. All these are important. You'd also want to consider stuff like central control. And what I mean by that is, as the administrator for whatever software, what control do I have over the user accounts for my organization? Can I control things like allowing or disallowing meeting recording? That's an important thing to control, right? What control do they have? All right. Consider how they handle outside users. Can outside users hop on a meeting? Do you want outside users to be able to hop into meetings? You probably do, but not every meeting. All right. So that's a little bit difficult to manage centrally. How do you know who's meeting about what? All right. So all these are important. These are also important. All right. Any questions so far? Evaluating software is a big task. Okay. So you got to consider everything. Okay. Whatever software you're running in an organization, that's not something that to take lightly. Because let's say you make a mistake. Let's say one of these you don't do. What could that lead to? Data breach, exactly. All right. So you definitely want to avoid that. All right, let's talk about load balancing. All right, load balancing is a fun topic. All right. So it's a really simple thing as well. All right, the idea of a load balancer is simply distributes tasks between different systems. And well, not different systems, because it's the same system. Different pieces of hardware. All right, so let's say we have a server rack. It's got a bunch of servers on it. Okay? So if they're all running about the same stuff, it means they can all theoretically do about the same stuff, right? Okay? So a load balancer is going to allow us to send certain packets to certain systems. A couple different algorithms we can use. Okay, random choice. It's going to randomly send different tasks to different servers. Okay, round robin. It's going to have it in a very organized fashion. So let's say this is server 1, 2, 3, 4, 5, 6. All right, random choice, it may do something like this. Okay, completely random. Round robin, it's going to go in an order. 1, 2, 3, 4, 5, 6. All right, load monitoring, so then would imply it's looking to see which has the most available resources. So let's say that server 3 has 90% utilized. Let's say that server 4 has 10% utilized. Which is it going to send it to? Server 4. Exactly right. How'd you figure that out? Exactly right. Okay. Preferencing or weighting. Let's say you say server 1 is the best server. It's just our favorite. All right. It's going to send everything it can to server 1. All right. And lastly, you got locality based. As the name would imply, it's whatever server is closest to the user. So instead of saying they're all in the same rack, let's say they're spread out throughout the United States. All right, let's say number 4 is closest to Colorado. Okay, so if I'm in Colorado, what's it going to send mine to? If it's locality based. Exactly right. Okay, because that's what's closest to me. Any questions? All right. Let's go through some stuff in network security now. This should be a review from last semester. Okay, so the idea behind tunneling is I want to encapsulate something in a standard packet. So, in general, we have an IPv4 packet. All right. Are we limited to only transmitting IPv4 standard TCP/IP stuff in it? We're limited to that. Can we transmit IPv6 and IPv4 packets? Yeah, we can through tunneling. Okay. So all we're doing is we're taking a standard packet and we're encapsulating some other stuff within it. So we have a virtual private network. Okay, that is a tunneling idea where basically we're encrypting the contents of the packet. All right. Similar with SSL and SSL VPN. All right. With a standard SSL or even TLS connection, it is going over HTTP, but it's encrypting the contents. All right. Point to point, very insecure in modern day. IPsec is going to be far preferred for both speed, reliability, and also just general security. Okay. Again, point to point, it's not really secure encryption. All right, it's going to be around 40 bits. Okay, that's pretty bad, all right? A lot of times it's going to be for security. But again, like we talked about last semester, we can use IPv4 packets to transmit IPv6 addresses. All right, that's a tunneling connection. Does that provide any additional security? In fact, arguably provides less security, right? Because what does IPv4 support that IPv6 does not? Well, I'm not going to say it doesn't, but it's seldom used because it doesn't really have an advantage. It starts with an N. It's 3 letters. Okay, it's a type of tunneling. Okay, NAT. All right. You guys remember network address tunneling? It's one of the slides today. So what that's doing is that's using the same public outbound IP for multiple systems. All right. It's technically possible with IPv6. However, there's not really as big of a need for it because what do we know about the address space in IPv6 versus IPv4? Specifically public addresses. Not that it makes a huge difference. We got more IPv4 or IPv6 addresses? 6. Okay. You know, you're talking billions versus smaller. All right. So this is what it looks like. Okay. We have the tunnel, and basically, tunnel is done router to router. Okay. Pretty self-explanatory. So VPN, I don't think we need to go over this in great detail. Kind of went over it last semester. But basically, what you're doing is you're just forming a connection using tunneling, and basically it allows you to access internal resources in that way. So Ron connecting to his company using a virtual private network, that's going to give him an address from his company router, right? Okay. So any resources the company may have that are limited to internal use, he can access because he has an address from that router. A couple different types. Okay, you got client to site. Okay, so that's where you have a client like Ron here connecting to his company. All right. Host to host, that will be on the same network. In some cases, this may be used. It's kind of rare. It's mostly used for server connections. All right, site to site. Someone throw me your favorite company that has multiple locations. Any company will work that has multiple locations. Any company with more than one location. Walmart. All right, Walmart certainly has multiple locations. So what Walmart could do, okay, they have their headquarters in Bentonville, Arkansas, right? Okay, they got a store in Durango, Colorado, okay? They could do a site-to-site VPN and have everything be on the same corporate network. Would they do that? Why or why not? It's actually kind of a trick question. Okay. Could you make an argument that they would do it for certain systems, but not for the entirety of Walmart, the store? Okay. What systems may they want to have on the corporate internal network? How about POS systems? Okay, point of sale. That's pretty important for credit card information to be not just on some random network, right? That's site to site. Okay. Extranet, it's going to be something where you have multiple providers, or not multiple providers, that's a bad way to phrase it. It's commonly used for industries. So, for instance, think about the gas industry. Okay, so oil. All right, we have OPEC, right? So, what is OPEC? Organization of what? What's the PEC? Exactly right. Okay, so OPEC may have an extranet, and that extranet would allow them to share information, communicate, that sort of thing. Let's face it. Okay, who's in OPEC? What region? Middle East. All right. It's not just one country. It's not just one company. It's a lot of different companies that are sharing information on there. So they may use an extranet to do that. All right, SSL. Okay. So basically, this is going to be operating on port 443. It's HTTPS. More modern term, or at least not a more modern term, more modern protocol, of course, would be TLS. But basically, what we're having is we're having the ability to access websites that are encrypted. Now, what makes this possible? What type of encryption makes this possible? Okay, so we know that SSH makes it possible, but more generally, what makes it possible? What's this? Okay, don't say it's an art project. What's asymmetric encryption? Ron, what's asymmetric encryption? So asymmetric encryption meaning that there's a public key that the website has. Okay, we can all get the public key. All right. And what we're doing is that we're requesting connection to it, it's granting us the connection. We're using the public key to encrypt, and then we're establishing an SSL connection. Okay. So that's very beneficial. Why does that benefit us? If we didn't have this sort of encryption, what would we do? Couldn't really transmit information securely, could we? At least not on a web page. All right, so IPsec. It's an important protocol to understand because it's the encryption used in most VPN connections. Of course, it's in layer 3. All right. So what's happening is we're taking the standard packet, we're just adding in, of course, the encrypted payload and header. All right. The other stuff, where it's going, where it's from, that's not encrypted. All right. But certainly the payload and the header is. So in other words, message body is going to be encrypted. All right, and then of course it's pretty straightforward. All right. So as we know, we have the payload, we have the TCP header, destination, source, and the IP header. All right. So we're just encrypting the payload and the TCP header. All right. Does that make sense? All right. So remote access. Talking a little bit more about this. All right. So of course we have remote desktop protocol. It's a pretty good protocol. You know. Is it not pretty neat that you can be thousands of miles away from a device and still access it? Is that not neat? That's pretty neat, in my opinion. 128-bit encryption, it's not amazing, but again, it's certainly adequate. All right. So the U.S. government, they would never lie to us, would they? They say 128-bit for symmetric is going to be fine. All right. Make of that what you will. I would still suggest not going below 256-bit. For RDP, you don't necessarily have a choice, though. All right, there will be a slight performance hit. And when you're talking about using a system in real time, that slight performance hit can be pretty noticeable, right? So let's say that you're using a system, all right? What's your favorite game? Okay, Minecraft. What's your frame rate you get? Okay, 120. Sort of input delay you get. Under 40 milliseconds. All right. So imagine if I came along and said, well, let's make that 120 milliseconds. Would that be pretty much unplayable at that point? Probably would be. All right. Frames per second could say the exact same. Okay. When you start adding that input lag, it becomes a big problem. All right. Does that make sense? So that's what that would do if you were to switch. And you won't necessarily even have the option to, but if you did, you'd have a lot more input delay. Now, it's not going to be as big of a deal. Let's just be honest. It's not going to be nearly as big of a deal on standard desktop tasks, right? But 120 milliseconds is a lot. Okay? And you would probably more likely, when you factor in all the different stuff involved, like transmission speed and just everything, it's fair to say it'd be probably around 250 to 350 milliseconds of input lag. That's going to be very noticeable, right? All right. So of course, with RDP, we can use a lot of different protocols. We of course can use TLS if we wanted, but there's not really a reason to, in my opinion. Let's use other. All right, so you got independent computing architecture, something that Citrix came up with. So it's a proprietary standard, and it's going to allow us to basically host applications remotely. So instead of hosting an entire system with something like RDP or VDI, what we're doing is we're hosting a specific application. All right, and this has some advantages. So do you want to have to sign into a completely different computer to access your time card, for instance? You probably don't. Or maybe you do. Maybe that's something you really enjoy, but most of you probably don't want to do that. Okay, much easier to sign on to a single application, right? All right. So, talked about managing user organization or managing user accounts. The key here is really automation. Right. You don't want to be spending your entire day touching user accounts. Okay, I'm assuming you don't, and that's something we're going to be working on Friday, by the way, is user accounts in Active Directory. All right, so you guys have installed Microsoft Server, or Windows Server, I mean. So we're going to actually go through this process together, creating user accounts, assigning them different roles, disabling them, that sort of thing. I think it'll be an important thing because, let's face it, at some point in your career, how many of you would like to be a system administrator? Anyone? Okay. How many of you want to do something in information security at some point? There's only a couple of us here. What job do you want to have? Okay. Cool. Huh. Well, I guess you guys aren't as excited about user accounts as I thought. That's okay, though. All right. So, of course, in Windows NT, they introduced the ability to limit activity for different users. Not really a huge reason you do this as a company, to be honest. There are some exceptions to that, though. So, let's say you had a company database. Is it fair to say you would limit the number of queries that a particular user does? I think that's probably fair to say. You definitely want to log everything for purposes of non-repudiation. Many other reasons as well. All right. I think it's been long enough I can talk about this. All right, there's a hospital up in Chicago. Okay, there's a pretty high-profile patient there. All right, and when that patient was there, Okay, they had, I think it was 14 nurses, if I'm not mistaken, who weren't working on this high-profile patient, but they accessed his file. All right, and guess what happened to those 14 nurses? They were fired. All right, you guys know the story I'm talking about? I'll give you guys a hint. They were just sentenced to 150 days in either jail or prison, not sure which. So make of that what you will. All right, I'm not stating an opinion on that. I'm just saying that that's an example, pretty high-profile case where people were fired for accessing the file. All right, so things like fail to ban. It's going to be very beneficial to apply to our accounts. All right, because we have an account, and what fail to ban is going to do is it's going to lock out the account after a certain number of failed attempts. All right, having things behind a firewall, okay, using multi-factor authentication. These are all very beneficial things to do. All right, password requirements. We've talked about these several times, just having good passwords. Haven't really in this class yet dived into what makes a good password. So NIST, which is National Institute of Standards and Technology, says you have no fewer than 8 characters. And they also state 3 different types of characters. Now, in 2022, is 8 characters truly enough? Probably not, okay? Probably want to start thinking about 10 to 12 as the minimum. But we're going by what NIST says. They say 8 minimum, 3 different types. That'll still take a couple minutes to crack, right? But let's face it, a couple minutes is not exactly an improbable amount of time to have. All right? You guys have been sitting in here for what? Close to 50 minutes, okay? So, imagine that we have more than a couple minutes. Certainly likely. All right? So using multi-factor authentication instead of expiring passwords, it's going to be very beneficial, okay? Because if you expire passwords, what are people going to do? They're going to write them down, right? Maybe slip it underneath the keyboard. They may also just use the same password and just increment 1 character. That's not really giving you a whole lot of security. All right, multi-factor authentication, on the other hand, they have to go in each time they sign in. They have to either input an external code, use some other piece of stuff that they may have, like, for instance, do a fingerprint scan. Anyone in the military? Ever serve in the military in here? Okay, so the military uses CAC cards. All right, that's something that you have. So most of the keyboards, they have a little spot to put it in, and that's a multi-factor authentication system. All right, so using single sign-on, that's going to be beneficial so people don't have to memorize a bunch of different passwords. Because what's going to happen if you have a system or you have different systems with each different password? What's going to happen? People can use the same password. So if you have one breach, it's all access. All right, similar, the idea of radius. All right, so radius, of course, is remote authentication, dial-in user service. Okay, it's a fancy way of saying it's going to allow us to use our standard Active Directory credentials to access a network. A lot of times this is going to be on a wireless network. However, it's not necessarily on a wireless network. In some cases, in fact, in a lot of cases, you may restrict access to physical LAN ports to 802.1x as well. All right? And again, all you're doing is you're having that layer of non-repudiation built in, so you know exactly who accessed what on your network. All right, and many other advantages as well. All right, so let's say, no matter how many employees you have, are you eventually going to fire someone, or at least have someone leave on not the best of terms? Okay. Maybe they get mad on their way out. Okay. So imagine if you had to change your password because you're using WPA2. Right? Not enterprise, just straight up WPA2. That'd be a real pain, would it not? Imagine you lose a device. All right? What do we know about the credentials for WPA2? Where are they stored? We talked about this last class. Where do we store the credentials for WPA2? First of all, it's a PSK, right? Okay, PSK means what? It means it's a pre-shared key, correct? So if it's pre-shared, where does it have to be stored? Okay, well, not a server, but where? So it's on the device it's using the network, right? So if you lose a device using standard WPA2, you have to change the password, right? At least you should. So that's what Radius is going to buy us. Okay, it's a lot easier to reset a user account password than it is to change everything, correct? Okay, so network access control. All right, a couple different things to discuss here. Okay, we have posture assessment. Okay, so what posture assessment does is it's going to scan each device for compliance with whatever policies we set. So for instance, let's say that one of our passwords, one of our policies is that it's running an antivirus program if it's a Windows computer. All right, is that a policy we can set? Easily. Okay, so posture assessment would go through and it would make sure that each of the devices on the network is compliant with that policy. All right, so there's a couple different appliances we may use for that. They probably do stuff like this in the residence halls. Okay, I don't know specifically, but a lot of universities use something called Safe Connect. Okay, do they use that here? Something similar? Never lived in a residence hall here, but that's what I would assume they have. And again, what that's doing is that's making sure that it's running whatever it says it should be in terms of the policies. Now, your policies can be whatever you want. All right. So theoretically, could we set a policy that the DNS server is set to someone throw me something crazy? Literally anything. Not a very crazy bunch today, are we? All right. We can set the DNS server to anything we want. We can set everything to whatever we want with our policies. All right. Guest network, pretty self-explanatory. Have a separate subnet and VLAN for guest devices to connect to, and still access the internet, but not access internal resources. Okay, captive portal. It's going to be used with unsecured networks, so not any sort of encryption taking place there, and it's just a website that people agree to terms and conditions to use the network. And finally, we have quarantine network. So a quarantine network, as the name would imply, is for devices that are infected. This can be done on a per port basis. All right, so let's say that we got a lab like this. Let's just say hypothetically, let's say this station's infected. All right. So what we could do is when we detect the infection, okay, get the port number, place that port on a quarantine network that can't access other resources. All right, is that a beneficial thing to do? Why? Exactly. So let's say it has a worm. All right, you don't want that worm to get all over the network. You don't really want it on anything, but if it's going to be on something, you'd want it to not be everywhere. All right, last thing for today is network address tunneling. So all we're doing here is we're using a different public IP address and a private IP address. And this is a technology that we generally think of as being specific to IP version 4. It's not really on IP version 6 because we don't need it, at least not yet. Okay? So when you talk about current population, you got millions of IP addresses per person. Yeah, why would you need to have something to dilute those? You don't. So let's do a quick little exercise here. I'm going to go ahead and end the recording because we pretty much covered everything.